Okay, in this video we'll look at a test for convergence of geometric series. Now just a reminder what a geometric series is. It starts with an initial term, and then all the following terms are all multiplied by a common ratio. And it will fall into this pattern right here. So the summation of a times r raised to the n power, where r is the common ratio and a is the initial term. Now this test is very easy to use. All it says is this, is that if the common ratio, if the absolute value of the common ratio is less than 1, then the series will converge. If the absolute value of the common ratio is greater than or equal to 1, then the series is going to diverge. Now, in most series, you got some tests. You can find out whether the series converges or not, but it's very difficult generally to find out the sum that it actually converges to. And one of the unique things about the geometric series is not only can you fairly easily find out whether it converges, but if it does converge, you can use this formula to find out the sum that it converges to. And this sum is just a, the first term divided by 1 minus r. And in most books it looks like this. You'll have a divided by 1 minus r, but what most people do, they remember it like this, is the first term divided by 1 minus r. Now the reason this is important, if the series should start at 0, this formula works just fine. But if the series starts as something else, suppose you wanted to go from 4 to infinity or 5 to infinity. If you start somewhere else, it's better to remember it in this form, and it'll make it work out better. Okay, now before we do some problems, let's take a quick look at where this sum formula comes from. And it would look like this. So the idea is I want to find the sum of an infinite geometric series. And the formula is going to be the sum is equal to a divided by 1 minus r. Now where the infinite sum comes from, it actually starts a little bit earlier trying to find the partial sum of a finite geometric series. So you might remember this formula from your Algebra 2 days. If you wanted to know what's the sum of the first 5 terms of a geometric series, then you could just let n equal 5. Here's the initial term, there's the common ratio. Plug a 5 in, and you could find the sum of the first 5 terms. But suppose you wanted to know the sum of all the terms. Then rather than stopping in at, say, 5, take the limit, and we'll go ahead and put this right here. So take the limit as n approaches infinity of this sum. Now, whatever you do to one side, got to do the same thing to the other side. So we'll take the limit as n approaches infinity of this term right here. Now, the only thing in here that's got an n in it is this r to the n, so let's think about that for a second. Now, first of all, the series can't converge unless the absolute value of r is less than 1. Remember, that comes from here. So if the absolute value of r is less than 1, it converges. And if you're saying it converges, that means that this ratio has to be less than 1. Now, what that allows you to do is this. If you take a number that's less than 1 and raise it to a power, suppose you had 0.8 to the n power. If you let n go off to infinity, then 0.8 to the nth power would go to 0. This term right here will go to 0. And what that leaves you with would be, here's the a, and now this turns into 1 minus 0 divided by 1 minus r. And of course, 1 minus 0 is just 1, so you'll get a divided by 1 minus r, and that's where this formula comes from down here. But again, you have to remember that this only works if it converges, so the absolute value of r has to be less than 1. If it didn't converge, then you'd take a number bigger than 1 to a power. This would go off to infinity, and it would, again, just confirm that it diverges. So that's where that comes from. So the sum of an infinite series is just taking the limit of the partial sum of a finite series. Okay, so now with that in mind, let's try a couple problems. And these are actually fairly easy problems to work with. Most people don't have a whole lot of trouble with them, so let's try them and see how they work. First problem looks like this. Now, if you're lucky, it will already be in this form. I think I'll write it down right here. It's in the summation of a times r raised to the n power. If you've got an initial term and you've got a common ratio. Now in this case, I'm going to go ahead and write out the first couple terms on this, and I would suggest you do this because it'll help you give you a good way of finding out what the first term is later on. So the idea is, if I let n equal 0, I'll have 4 times anything to the 0 power is 1, so the first term is going to be a 4. Then if you let n equal 1, you'd have 4 times 1/2, which would give you a 2, so this is going to become plus 2. Then, now another way of doing it is just to take each term and multiply it by the common ratio, because that's what it is. So 4 times 1/2 is 2, times 1/2 is 1, times 1/2 is 1/2, times 1/2 is 1/4, and so on. And if you just kept adding these things up, somewhere out here, they're going to equal to, and we'll just put a little box right here for right now, they're going to equal up to some sum. Okay, now, what makes these problems easier, if it happens to be in this form, then right away you know this. There's the ratio, common ratio, and you know that R is equal to 1/2. So you know that the common ratio is 1/2. So right away, according to the rule, if the absolute value of the ratio is less than 1, which it is, then this thing converges. So you know that it converges, and you can use this formula to find out what it converges to. So right now, with this, at this point, you know that this series converges. But what does it converge to? Well, then you'll try the sum. So the sum is equal to the first term, and I think I'll put a little box around this. It's equal to the first term divided by 1 minus r. So what I've got is, in this case, I'll go back to black again. I've got 4 divided by 1 minus r, and r is 1/2. So that gives me 4, and then 1 minus 1/2 would be 1/2. If I invert and multiply, I have 2 over 1, which would be 8. And that is going to be the sum that it converges to. So this entire thing converges to 8. So if you added up all these numbers to infinity, you get this. So really, looking back at the rules, it's just a matter, first of all, of try to get it in this form and see what R is. If the ratio is less than 1, it converges. If the ratio is greater than or equal to 1, it diverges. And then if it does converge, you'll be able to figure out the sum that it converges to using this formula. So let's try a couple more problems. Okay, and this one. Now, this is exactly the same thing as the problem we just got finished with. The only difference is that last problem started at 0. This problem starts at 3. And this is a good reason for writing out the terms and so on before we get started. So again, I'm going to begin by saying I want to try to get it in this form. Summation of a times r raised to the n power. Again, I'll write out the first few terms on this one, but let's go back and take a quick look at that last one. It went 4, 2, 1, 1/2, and so on. Now this one's going to be a little different. When n is equal to 3, you'd have 4 times 1/2 to the third power, which would be 1 over 2 cubed, which would be 4 times 1/8, which would be 1/2. So in this case, the first term, if you start with n equals 3, is 1/2. Now the next term, if you let n equal 4, you'd have 4 times 1/16, which would be 1/4. But also remember, you can just take each term and multiply it by 1/2. So 1/2 times 1/2 gives you 1/4. Times 1/2 will give you 1/8, and so on. And then this thing will go on forever. So now you're asking the same question is, does it converge? And if it converges, what does it converge to? So first of all, does it converge? Well, it's already in this form, so that is the common ratio right there. This one's going to be pretty easy. The common ratio is 1/2. So again, going back to your rule, since the ratio is less than 1, you know that this thing converges, which tells you at this point, you know that this is going to converge. But what's it going to converge to? Now, real quickly, let's go back and look at the last one. The last one started at 0, same series, but it started at 0. This sum converged to 8. So now let's see what this one does. Okay, now, again, I'll use the same formula. I want to find the sum. So the sum is equal to the first term. But again, this is a good reason for writing these things out. What is the first term? Now, in that last problem, let's go back and take a quick look at it again. In that last problem, the first term was 4 because you started at 0. But in this problem, the first term is 1/2 because you started at 3. So it's going to be the first term, which is 1/2, divided by 1 minus the common ratio. So it'll look like that. Now what that's going to be would be 1/2 divided by 1/2, and 1/2 divided by 1/2 is 1, and that's going to be the sum. So if you were to add all these things up, they would add up to 1. So you found out, first of all, that the series did converge, and that it actually converged to 1. So it does make a difference where it starts, and that's why I would use this form right here. Rather than using a sub 0, you may be tempted to plug in the wrong number. If you write out the first few terms and always plug in the first terms, then the sum thing will work out right. Okay, next problem. Let's try this one. Suppose we have one, the ratio could be negative. Now again, I'm going to do the same thing as just write out the first few terms of this thing. So when n is equal to 0, I would just have anything that's 0 powers 1, so I'd have 5. Then when n is equal to 1, I'll multiply this by 5 times a negative 3/2, which would give me a negative 15/2. Then again, times a negative 3/2 would give me a positive 45 over 4. Then back to a negative, and off it goes. So now the question is, does this thing converge? And if it converges, what does it converge to? So again, you'd like to get it in the form a times r raised to the n power. And if you're lucky, it's already in that form, and that's what this is. Here's the initial term. It's already in this form, and again, this is r. So on this problem, you know that r is a negative 3/2. Okay, so now the question is, does it converge or diverge? We'll go back to your definition. 3/2, actually negative 3/2, the absolute value of it turns into a positive 3/2. 3/2 is greater than or equal to 1, so this series is going to diverge. So since the absolute value of r is greater than 1, that means that this series is going to diverge. So the series diverges. Now in this case, you don't have to worry about the sum because, remember, the sum only exists if the series converges. If the series diverges, there is no sum, so you don't even have to do that step. Okay, next problem. We'll take a look at a couple more variations on some of these. Sometimes it'll be written in this form right here, and this is really just a matter of playing around with the algebra to make it work out right. So you've got 3 to the n minus 1 over 4 to the n. Now you'd like to try to get it again in this form right here, the summation of a times a common ratio raised to the n power. But sometimes it's difficult to recognize that this thing will actually turn into a geometric series. It doesn't look like it to start with. First of all, it doesn't look like it has an a, and there's some question about what the common ratio is. So again, you just begin to play with these. So I'm going to write this as the summation, and I'll put a little thing here. And the idea is to break it down into parts using your exponent rules. So this is going to go from n equals 0 out to infinity. And I'm going to take this and rewrite it like this. 3 to the n times 3 to the negative 1. Remember, if you add the exponents, it would be this. And I'll do this one too. I'll break this one up. This would be 4 to the n times 4 to the 1. Because again, n plus 1 would give you n plus 1. N plus a negative 1 would give you this. So rewrite it and expand them into different exponents. Okay, now it's just a matter of playing around with it. Next thing I'll do is make this be the summation from n equals 0 to infinity of, and we'll go across to here. The next thing I'm going to do is to take this 3 to the negative 1 and move it down and make it be a 3 to the positive 1. So I'll wind up with positive exponents. So that's going to give me a 3 to the n in top. I've still got the 4 to the n in the bottom. I've got the 4 to the first power in the bottom. And now I took this 3 to the negative 1, move it to the bottom, make it be 3 to the positive 1. So I'm just playing around with the exponent. Okay, I'll make this be the summation from n equals 0 to infinity. And again, we'll modify a couple things here. Okay, first of all, I'm going to take the 4 and the 3 and just multiply them together and get a 12. Then in the top, I've got 3 to the n, and the only other terms left in the bottom is this 4 to the n. So I've got it looks like that. And this is a times right here. So now, again, we'll rewrite this as n equals 0 to infinity. And I'll make this be 1 over 12. And I'm going to take both of these and I'll group them together and make it be 3 to the n over 4 to the n. So I just group things a little differently there. Take this one, summation n equals 0 to infinity of 1/12. And now you can write this as, since both those are raised to the n power, you can write it as 3/4, the whole thing raised to the n power. Now finally, after all this work, you've got it in the form of a geometric series. So that's going to be A, and that's going to be R. So here's the things you know at this point. Now the question is, does it converge or diverge? Well, again, just looking at the common ratio, that term right there, you can see that R is equal to 3/4. And again, since the absolute value of the common ratio is less than 1, using your rule here, so the absolute value of the common ratio is less than 1, it converges. So this thing is going, you know that this series is going to converge. But now the question is, what does it converge to? So again, we'll do our sum again. So the sum is equal to, now again, if you wanted to write out the first few terms of this thing, we'll go ahead and do that. If this is equal to 0, then anything to the 0 power would be 1. So the first term of this series is going to be 1/12. Plus, now, if you wrote out the second term, when n is equal to 1, you'd have 1/12 times 3/4. And if you canceled out all the numbers, this will be 1/16 plus, and it goes on to the other one. But what I'm really interested in here is just the first term. The first term is going to be 1/12. The sum would be 1/12 divided by 1 minus the common ratio, which is 3/4. So that's going to be 1/12 divided by 1/4. Invert and multiply, I'll have 1 over 12 times 4 over 1. And this will all come down to 1/3. So this is going to be the number that it converges to. That's going to be equal to the sum. So that's an example to show you that sometimes, if you're lucky, they'll be in this A times R to the n form. If you're not lucky, this one didn't look at all like a geometric series when you started, but the idea is just play with the exponents and the rules of exponents and try to manipulate it into the form A times R to the n. Once you've got it in this form, then you can apply the rules for a geometric series. And let's try one more example. Okay, now in this last example here, what we've got is it's in its expanded form, and the idea is that you can change it into the form, and again, we'll go back to the same one we started with. You want to get it in the form A times R raised to the n power. Okay, now to do this is the first term is going to be this right here. You can just look at it and tell. That's going to be A sub 0, or the first term of the sequence. So you can come down and make this be the summation of, right here, the summation of, the first term is 5, and now the only question is, what is the common ratio raised to the n term? So we'll let this go from n equals 0 off to infinity. Now again, to remind you, if you've got a geometric series, you can always find the ratio like this. So the common ratio of any geometric series, it's always the next term divided by the previous term. So if you take any term and divide it by the previous term, you'll have the common ratio. So in this case, let's just go ahead and take this one. Let's take this term and divide it by the term in front of it. So it would be 5/4 divided by, now in this case, this term was a negative 5/2. So again, invert and multiply, that's going to be 5/4. And you're going to multiply it by a negative 2/5. In this case, the 5s will cancel out. This will turn into a negative 1/2, and that's going to be the common ratio. So there's the common ratio. And you can kind of check it by going up here and doing this. You start with 5 times a negative 1/2 gives you a negative 5/2. Times a negative 1/2 gives you a positive 5/4. Times a negative 1/2 gives you a negative 5/8, and so on. So you can check your answer like that. So now you know that r is equal to a negative 1/2. Well, now you've got this thing in the right form. So the next question is, does it converge or diverge? Well, again, look at r. In this case, r is equal to a negative 1/2. And using your rules, the absolute value of a negative 1/2 is less than 1. So you know that this series converges. But again, what does it converge to? So to find out what it converges to, we'll do the sum. The sum would be the first term, which is 5, divided by 1 minus the common ratio, but the common ratio is a negative 1/2. So that's going to give you 5. This would be 1 plus 1/2, which would be 5 divided by 3/2, which would be 5 times 2/3, which would finally get you to 10/3. And that's going to be the sum that it sums up to. Okay, so you can show it like that. So anyway, it could be in different forms. Now, in most of these problems, if you're lucky, it will already be in this a times r to the n form. If you're not lucky, you may have to do kind of like what you did right here, is just play around with it until you eventually get it in that form, and then you just look at the ratios of these things. So if the absolute value of the ratio is less than 1, it converges. If it's greater than 1, it diverges. But in this case, if it does converge, you can use this formula to quickly find out what the sum is. So that's just a quick look at geometric series. And it's actually a fairly easy test to use once you get it in the proper form.